So for 9.2, we're just solving by graphing, which is just review. As long as your equation is set equal to 0, we can graph it and just identify where the x-intercepts are, if there are any, and those are your solutions, right? We said those words were all interchangeable back in Unit 8. We said the solutions, the zeros, the roots, the x-intercepts, those all mean the same thing, okay? So we're just going to practice graphing our parabola and then identifying where it appears to intercept the x-axis and just listing where those values are, okay? So quick step-by-step here. First, make sure that your equation is properly set up for us to graph it. That means it's in standard form on this side, ax squared plus bx plus c, just in degree order from highest to lowest, and that it's equal to 0 on the other side. Okay? Then, once you have it written like that, you graph it. You graph your parabola. And once you have the graph in front of you, you find those x-intercepts and you list them and you describe what they are. And that's it. That's all we're doing. Wherever those intercepts are located, those are the solutions to that equation, to that quadratic equation. Okay? So that's what we're doing today, and a lot of that is review. Okay? And because they're exactly the same thing, they go right hand in hand, right? A quadratic parabola or a quadratic equation is going to have two real solutions if it has two x-intercepts. Okay? So that means that a lot of times we have a graph and we'll notice our parabola strikes that x-axis at two different places. So those can have two solutions because of that symmetrical U-shaped curve that the parabolas have, right? So a lot of times it has two solutions if it has two x-intercepts. Sometimes, though, it only has one x-intercept, which means it only has one real solution. And that might look something like, let's see, I'll put it over here. You might have a parabola that looks more like this, where it just barely, well, no, a little further. There you go. Barely touches. That looks more like a V. Let's try that. Let's try that again. None of this is working. Let's erase. There you go. But your parabola might just barely come down and then come right back up, and it only intersects that x-axis at one location. If the vertex is the one point that touches that x-axis, then that's the one solution. So sometimes there's only one x-intercept, and that means one solution. And then the last one is, those two examples. The last one is if you have a graph, sometimes your parabola doesn't come right up high enough to actually reach the x-axis. Or maybe it's like floating above it like this, but doesn't go low enough to reach the x-axis. If there is no x-intercept, then there is no solutions. No real solutions, at least, to that particular quadratic. Okay? So you could have any one of those three different scenarios at play when you graph a quadratic equation. Okay? So these first ones are just nice and easy. The graph is actually already provided, right? So we're just focusing right now, making sure we feel clear that what we're looking for when we do have the graph in front of us is the what, guys? The x-intercepts. Where does it hit the x-axis? We're looking for those x-intercepts, right? So if I look at number 1, the graph is actually already created for me, okay? My equation's already set equal to 0. So all I have to do is identify right in here, where does this appear to intersect the x-axis? So what number does that appear to intercept at? At 1, yeah, and at -4. So guys, that's it. You just solved the quadratic. That is your solution. This particular quadratic has two solutions. Either one of those numbers, if I plug it back into the original, makes it true. And are the only numbers that make it true. Okay? And so that's the solution to the equation. But in a graph, the nice, easy way to find them is to identify those x-intercepts. Okay? So this one had two solutions. They were at -4 and 1. How many solutions does number 2 have? Also 2, right? It intercepts the x-axis twice. Where do those solutions appear to be? At x equals 2 and x equals 5. Yes, folks, it is that simple. That's it. Okay? Now, of course, these are nice because they provided the graph for us, right? Part of it will be that we'll be creating our parabolas for a lot of the problems. Before that, though, before we start creating the parabola, we want to make sure that that first step in our step-by-step a minute ago up here, right? That we are in standard form equal to 0. That's step 1, right? So before we begin, let's just practice making sure that we are in standard form equal to 0. That means that we rewrite this so that all of the terms are together on one side in the proper order, right? The second degree, first degree, and constant. And then there's nothing on the other side. Okay? So if it's already given to us in that way, then that's awesome. But if not, then we want to make sure we rewrite it like this before we start the graphing. Okay? So if I look at number 3, is that one in standard form already? And equal to 0? No, right? So we'll move, right, just to practice. It's been a long spring break. All we have to do is just do the opposite sign. On this side, I'll make sure to write the 3x squared first because it's a higher degree, and then the negative 15. And now I don't have anything left on the right side. And that's all I had to do. Okay? It's in standard form from highest to lowest degree. Everything is together on one side. It's equal to 0 on the other side. That's all you have to do. And then you would be able to proceed to graphing. Okay? Number 4. Same thing. It's not equal. I could move the 14, or maybe even better yet, I could also move the x squared. I like that because it makes my a positive. But both work. So if I move that over, I've got 0 on this side. On the left equals that positive x squared with a negative 14. And if that bothers you, you can always rewrite it. So the 0 is on this side if you want. Okay, but now it's in standard form. Okay. Is number 5 in standard form? Do you have a question? Great question. So remember back a few units ago, probably in the fall, we talked about proper standard form, especially with linears. Proper, if I was like being really specific about it being proper standard, you would want a to not just be positive, but to be a whole number. And we wouldn't want to leave a fraction or a decimal or a negative in a. I'm not going to be that picky here. I'm not going to take off for that. Really, yes, we want it in standard form so we can graph it effectively, but we kind of have a different end game in mind right now, and that's just graphing our parabola to find those x-intercepts. And so it doesn't. I won't take off if you have it the other way. Okay. However, and I don't know if this is where your mind might be going, right? If I move, so she's asking, what if you had moved like the 14 over the other way, right? Would I still get the exact same parabola? Right? Because the other option would have been to add 14. But then I would have ended up with negative x squared plus 14 equals 0. Are these parabolas the same parabola? Good. I agree. They're not. Okay, this one opens upward. It has a y-intercept at negative 14. This one opens downward. It has a y-intercept at positive. They're not going to be the same parabola. But here's the cool part. What is it that we're doing here? We're doing this to what? Guess what? The x-intercepts are the same. Different parabolas, but the x-intercept ends up being exactly the same answer. So, depending on which way you kind of manipulate things, sometimes you'll get a parabola, you really will get a reflected version, but those intercepts along the x-axis are exactly the same correct solution. So it doesn't really matter which way you do it. Okay? All right, good question. All right, last one though. This one I have a couple of things. So I do want to switch the order here so that my degree 2 is first, but I also need to move the 5. So I'm going to do all of that. Not a 15, a 5. Okay? So here, I'll move the 2x squared in front, then the 4x, and then the negative 5 I just moved, and then it's in standard. So are we feeling okay with writing it in standard form and equal to 0? Everybody's okay with that? All right. Well, then let's go on to actually graphing our parabolas so that we can solve them. Okay? This is where you can use the calculator. Okay, and I'm going to show you exactly what I would want, you know, what I'm okay with and what I'm not okay with. So, number 6, solve the equation by graphing, write the equation in standard form. Let's take a look at 6 first of all. Is it already in standard form equal to 0? Yeah, so that's already done for us. Feel free to just like, okay, yeah, it's already there. Half our work is done. Sounds good, okay? But second of all is graphing it. This is where I am okay with you. Oh, I thought I had my graphing calculator up here. Grabbing your graphing calculator. Let me pull that up for you guys. And using the table to find your points. Okay? So I'm not going to make you have to create all these points, computing all of them. You can use your calculator for that, but after that, I'm not okay with you graphing it on the calculator. You have to make your graph. I'm just allowing y'all to pull up the points quickly instead of having to find every single one. Okay? So we can pull up our calculator here. Let me click that. Come here to my y equals. And I'll just enter our equation here. So for number 6, we agreed it was going to be x squared plus 4x. That was already in standard form equal to 0. And then I'll just go second graph, pull up our table of values. And that's all I'm okay with you using the calculator for, is to look at this and say, okay, here's a bunch of points I can plot right in here, right? I can see that my parabola goes through negative 5, 5, negative 4, 0, negative 3, 3. So I have all of these ordered pairs that I can then now go in and graph them. But you do have to graph them. I'm just not making you plug in each one and solve them. Does that make sense? Okay. So here I'll come in and say, okay, we had a point at negative 5, 5. We had a point at negative 4, 0. We had a point at negative 3, negative 3, negative 3. We had one at negative 2, negative 4. And then we had one at negative 1, negative 3. So it starts to come back up. And then there was one at the origin. And there was one at 1, 5. All right, so there's our parabola. So I'm okay with y'all looking at the table on the calculator, but you still have to graph this, like actually plot the points and make your parabola. And now we just have to identify where those x-intercepts are located. So where does it appear to intersect the x-axis? At x equals, what do y'all think? Negative 4 and x equals 0. And those are your solutions. That's it. Okay? How do we feel about this? Are we okay? How about number 7? Is that already in standard form equal to 0? No, right? So let's fix that. I think the easiest, quickest way here is to actually add the x squared to the right side. Right? I only have to move one thing and it makes it positive. So that leaves me with a positive x squared, a negative 2x, plus 1, and nothing on the other side. So now we are in standard form equal to 0, and we can graph it. So this is where we grab our calculator. We're done with number 6, so let's clear that equation. So do zoom 6. Do zoom 6, and that will take you back to we're using the table right now anyway, but that'll put you back at a 4-quadrant grid. Okay? Okay, so for this one, we agreed it was x squared minus 2x. And then plus 1. Is that what y'all got? And we're pulling up the table of values. Looks like within my coordinate grid, looks like I could plot negative 1, 4, 0, 1, 1, 0, 2, 1, 3, 4. All of those points will work. So let's go back to the graph. So I had a point at negative 1, 4, 0, 1, 1, 0, 2, 1, and 3, 4. So how many solutions is this going to have? Just one real solution. Where does that solution appear to be, guys? At x equals what? At x equals 1, right? So at x equals 1, that's what we need to do, is label these guys. Okay, so x equals 1 is the only solution for that one. That one only has one real solution because it only has one x-intercept. That's it. It does not show. So make sure that you are using a minus between the two, in front of that 2, because you're using a negative, so it's multiplying that. In fact, it probably graphs as a cubic. Yep, see, do you see that curve? So it's not even quadratic, because it's multiplying those first 2 terms. So make sure you actually use, it shouldn't make a difference, but it does. Try it now. Okay? All right. Better? Yeah. All right, good. Let's try number 8. Is it already in standard form and equal to 0? Yes. Right? So this part it's already done. It's already x squared plus 2x plus 4 equals 0. Looks good. Let's pull up some points we can graph. So we're looking at x squared plus 2x plus 4. And then when we pull up a table of values, we've got negative 3, 7, negative 2, 4, negative 1, 3, 0, 4, 1, 7. This will probably all be pretty close to fit. So let's graph it. So I heard negative 3, 7, right, which kind of falls right out here. And then we also had negative 1, 4. Is that right? Yeah. No. Just kidding. I was looking at the wrong one. Sorry. All right. So, well, this one was right. Then it's negative 2, 4, negative 1, 3. And then it comes back up and back there. So here's our parabola. So, how many solutions does this have? None, right? No x-intercepts means no real solutions. So, if it doesn't intersect that x-axis, then no real solution. Okay? How do y'all feel about the lesson? Are we okay? That's pretty much, that's the idea right there. Okay? Y'all want to do a couple more? Y'all feel good about these? That's it. All you're doing is graphing the parabola. Use your calculator to pull up the table, but do make a graph, and then just identify where the x-intercepts are. That's it. Okay? It could have 2, it could have 1, it could have none. Okay? So if y'all feel good about these, and I don't think we need to do a whole bunch more, but I do want y'all to look at 12 through 14. So do me a favor. Let's go to 12 through 14. Because, are these parabolas? No, they're not. Okay? These are not parabolas. They look weird. They look really different. These are actually cubic functions. Every one of these are cubic. If we simplified our equations out, we would get polynomials that the highest degree is 3. Okay, so these are all cubic. So that can be intimidating. They look weird. But here's the deal. Here's the moral of the story. If they want the zeros, which is just another fancy word for the solutions, we're still just looking for what, guys? The x-intercepts. Okay, that's it. So don't let this intimidate you, because all we're still doing is, hey, they graphed it for us. Awesome. We're just looking for the x-intercepts, right? So if you look at number 12, I just want to see if I can identify at what location this curve is intersecting the x-axis. First of all, how many times does this hit the x-axis? 3 times. Guess what? Because it's a cubic function. Highest degree is 3, right? Quadratics have a highest degree of 2. So the most solutions they're going to have is 2, right? So quadratics have 2, 1, or 0. Cubics are degree 3. They could have 3, or sometimes 2, or sometimes 1. Okay? Actually, I don't think a cubic can have none. But that's a good, yeah, because it ends both. Yeah, at some point, because it's infinite in both directions. So, anyway, but it can have 1, 2, or 3. Okay? If it has none, I'd have to think about that, but I don't think so. Okay. So what are locations? Like if we were to solve 12, where does it look like it's intercepting the x-axis? At 0, at what? 1, and 2. There you go. You just solved your first cubic equation. Not bad, right? How about this one? How many solutions does it have? 2 solutions. One is located at -2. The other is at 1. Right? How about this guy? How many solutions? Number 14 has 3 solutions. They appear to be at -1, +1, and at 3. All right. Thumbs up, down. How do we feel? That's it. So we're solving by graphing by just finding those x-intercepts.